see our router, giga 0 by 0 is connecting to the switch. Router 1, router 2, and router 3. Now after that, we need to add the serial ports. Just click on the router. We have a power off. We need to turn it off. There is a switch. And drag the WAN interface card. Then on the device. Turn it off the router. Drag and drop the interfaces. Then power on again. So we need to connect router to router. Take the serial connection. Click router serial 000, serial 000. Again here serial 01 by 0, serial 01 by 0. I want to give this giga 00. The IP address is 192.1.1.254. Here I'll give like 172.16.0.254. Let me give here 10.0.0.254. I want to make subnet of this network yesterday's class VLAN 199.10.1.1 with /30. And here it is 199.10.1.2 with /30. And here I'll give 200.10.1.2 /30. And 200.10.1.1 /30. This is 199, 199, 210.1.2, 210.1.1. So if it is 192.1.254, this PC address will be 192.168.1.1. Next will be 192.168.1.2. 170 above, so 170.16.0.1. 170.16.0.2. It's 10, 10.0.0.1, 10.0.0.0.2. So let me configure these interfaces. Host name is R1. Interface giga 0 by 0. And its IP address is 192.168.254, 255.255.255.0. Type no shutdown. Interface serial 0 by 0 by 0. Its IP address is 199.10.1.1 /30 means it is 252. IP address, then don't type, that is a topology. CID notation, don't type /30 like this. As an example, a topology. So /30 indicates that the subnet mask is 255.255.252. Like shutdown, encapsulation, DLC, and clock rate 64,000. Then we need to assign the IP address for these pieces. 192.168.1.1, 192.168.254. This should be 192.168.1.2, 192.168.1.2. 0.25. Insert 0.2. 0.25. 16.001. 0.25. So router 1 is done and we need to configure router 2. Interface reader 0/0. The IP address is insert 16 root and 7 to 16 0.25. The right command is the topology. I want to save this lab file save as on the desktop string lab. The DNA testing lab should be created. If I close and if I open the testing lab tomorrow, so like I don't want to reconfigure it again. So all the things should be there. So in today's class, we are going to learn about the age RT. When you're going for age RT stands for Enhanced Interior Gateway Routing Protocol. It is an Enhanced Interior Gateway Routing Protocol. Age RT is an Cisco proprietary. Age RT is a Cisco proprietary protocol. Proprietary until 2030. But now standardized. Age RT, it is a IGP, a distance vector, dynamic routing protocol. AJRP advertises routes in the same autonomous system. From 1 to 65,000. Why the difference? Let's explain this. So when you are going for AJRP, AJRP is an enhanced interior gateway routing protocol. It is an enhanced of IGRP. So before AJRP, there was a protocol called IGRP. So the IGRP routing protocol has modified as a new protocol, and they give the name as enhanced. So AJRP is an Cisco proprietary until 2013. Now we are there in 2023. So before 10 years maybe, yeah, before exactly 10 years into, yeah, from last 10 year it became as standardized. But until 2013, AJRP is configured only on the Cisco devices only. So, and the AJRP is a distance vector dynamic IGP routing protocol. You remember the routing? The routing are of three types. We have like static, we have the dynamic, again we have the default. Again, the dynamic routing protocols are divided into two types. We have like IGP and DGP. They have IGP and EGP. When you are going for the IGP again, the IGP routing protocols are divided into two more types. We have a distance vector. We have distance vector. Again, we have a link state. So in the distance vector, we have the RAIP, we have the IGRP, and again we have the AJRP. So EAJRP is enhanced of IGRP. It's a distance vector IGP dynamic routing protocol. It falls back under the distance vector. EAJRP is going to advertise the routes within the same autonomous system. You see, I have a router and I have another router. This router 1 is connected with router 2. Router 1 and router 2. In the router 1, if I'm configuring, like say, router EAJRP, if I define 100, in the router 2 also I must configure with the same number. Router EAJRP 100. They must be in the same autonomous system number. If one router is in router EAJRP 100, if another router is in router EAJRP 10, they are being advertising with the different AS, different numbers actually. So they cannot make neighbor relationship or they cannot advertise the information. They are not going to work. AJRP is going to advertise the routes within the same autonomous system number and supports 1 to 65,535 autonomous systems are going to be supported. Maximum hops that the AJRP is supporting is 255. Within a single autonomous system, you can advertise, you can have like 255, 255 hops can be connected. And the default administrative distance for AHRP routes, we have 90, the routes that are coming from within the BGP domain, and 170 is for external routes. I can say it's 90 for the internal AHRP routes. But when you are going for like a 170 are these are the routes that belongs to the other them as external routes. Sir, what you are saying? I have some 3 routers are there. This is 1, 2, and 3. Last class will and read. So here they are using some routing protocol called RIP. Of course, this router 3 has a LAN network. Take router 2 also has a LAN network. They are advertised with RIP. But this side, router 1, router 2 again, they have some networks are here. You configured with EHRP. So EHRP can communicate here. But RIP can communicate here. But RIP cannot communicate with EHRP cannot communicate with RIP. So the middle router, what it has to do, it has to redistribute the RIP routes into the EHRP domain, EHRP into the RIP. So the router who is redistributing, actually the middle router should redistribute. When he is redistributing the route, those routes are called as external routes, and the external routes by default will have that mutual distance with 170, not 172, 170. 170. 170 is the initiated distance for external routes. And of course, yes, EHRP is going to use dual diffusing update algorithm, and according to this algorithm, EHRP is going to calculate something called best path, that is called metric. METRS metric is equal to, we have a bandwidth plus we have a load, or let us go with the load, yeah. Then we have a delay, we have an MTU, and again we have some reliability. All these are the 5 K values. Bandwidth should be like K1, load is K0, and delay is also K0, sorry K1, MTU is K0, and reliability is also K0. So the K0s are excluded. They are excluded in calculation. So EHRP is going to calculate the best path based on the bandwidth and delay. Shortcut you can ask, somebody will ask you like what is the best path that the EHRP is going to use, bandwidth and the delay. RIP is going to calculate the best path based on the least hops. We have different types of the EHRP. You have the EHRP packets. You have like an hello. You have an update. You have a acknowledgement. You have query. Then you have reply. I have a router 1 and router 2. I have a router 1 and router 2. When you configure EHRP, in the router 1, router EHRP 1, take for example, you advertise the serial network. Then router 1 continuously sends hello message for every 5 seconds to router 2. Hellos are sent for every 5 seconds. 5 seconds, yes. And soon after, in the router 2 also, when you configure router EHRP 1, the autonomous system, when you advertise the network, see here, that serial network, when you advertise, or when you advertise the fast Ethernet, or when you advertise any other interfaces, for every interface, on the every interface, for every 5 seconds, it sends hello message for every device. When a router send and receive hello message, then they make something called EHRP neighbor relationship. For example, I come to the class, I ask hello Rafik. So Rafik says, hello sir, how are you? So when I send and receive hello message, then the neighbors are being established. So once the neighbors are being established only, then the router is going to update, means is going to advertise his network's information, his fast Ethernet, what networks is connected to router 2, and router 2 also what networks it is connected, what you advertise in the AHRP domain is going to advertise to router 1 by using AHRP update messages. Of course, AHRP allows are multicasted by using the IP address of 224.0.0.10. What I'm saying, it is going to multicast this address 224.0.0.10. Updates will be always unicasted. In some scenarios, it also will be multicasted actually, the broadcast type of network. But here always we say updates will be unicasted. So when you say like an update means it is going to advertise the routes by default. For every update, there will be an acknowledgement message. And sometime, if router 1 is configured with AHRP, router 2 also is configured with AHRP, neighbors are established. In some scenario, router 2 will not advertise the routes to router 1, for example, it's very slow. So still router 1 can ask for updates. Asking for updates is for query. What is query? Query asks for updates. And for every query, there will be a reply message. Sir, what you are speaking, we are going to discuss these things are the AHRP packets by default. Hello message, hello packet, update packet, acknowledgement, query, and reply. These are the internal packets will be sent and received from router 1 to router 2. And AHRP is going to maintain its own the tables. Say AHRP tables. The first table that the AHRP maintains is AHRP neighbor table. AHRP neighbor table. So what is a neighbor? A neighbor is a device which is directly connected. So in our topology, router 1 is connected to router 2. So router 2 becomes a neighbor for router 1. Router 3 is directly connected with router 2. So router 2 become a neighbor for router 3. But for router 2, how many neighbors? Router 1 and router 3. 2 neighbors are there. Their neighbor information will be maintained. AHRP is going to maintain. AHRP maintains the best path and the backup path. The topology called as AHRP topology table. Because AHRP is the only one protocol that maintains the primary path and its backup path. I'll explain one minute. And also, we have the AHRP route table. So the separate tables are being maintained by the AHRP. Wait. Take for example, AHRP is the only one protocol always going to calculate the best path based on the bandwidth and the delay. I said AHRP is a distance factor. Let me give some numbering for this. Router 1, 2, 3, 4, 5. Always AHRP is going to calculate something called as FD value. Called like is distance. Also, it is going to calculate something called as advertised distance. And when you are going for like an free value, feasible distance, it is a total distance from source to the destination. But when you are going for advertised distance, it is a distance from neighbor to the destination as well. This advertised distance is also known as reported. It's not, some people they use this reported distance. Reported distance as well. But most commonly, that what we use is advertised distance only. Now, what do you mean by advertised distance? It is a distance from neighbor to the destination. See, router 5 has its own distance. Distance means it's not in kilometer. It is in bandwidth and the delay. Okay, for example, it has 100 Mbps. And what this router 4 will do? Router 4 will advertise the distance of router 4 to router 5, the bandwidth, and router 5 to router LAN to the router 3. Router 3 will advertise his router 4 and router 5 to router 2. Router 2 will advertise everything. Take for example, from router 1 to router 2 is 100. Router 2 to router 3 is 50. Router 3 to router 4 is 20. Router 5 to router 3 is 30. So when you say FD value, it is a total distance from the source to destination. 100 plus 50, 150, 20 plus 30. So here the FD value is 200. FD value is 200. Now when you say like an AD, it is an advertised distance. It is a distance from neighbor to the destination. 50, 20, 70 plus 30, 100. Always FD value will be greater than AD value. FD will be greater than AD. Understanding? Rafiq, Abdul, Pranay?
Yes, sir. Yes, sir. Yes, sir.
Abdul? Rafiq? Hello, Muhammad Rafiq. So, anyway, if for example I have a router 1, I have router A, B, C, D, and E, F, D, H. Router is connected B and D and E, F. D is connected C. So I want to reach from router A to router C, for example. I want to reach from router A to router C. reach from router A to router C, always router A is going to calculate something called as FD value and also AD value, and all three paths. Now to reach from router A to router C, there are three paths are there. There are three paths. Okay. In the first path, here the FD value is this is the source and this is the destination. 1000 plus 1000, 2000 is 2000, and the second 2000. The second one is 1000, 1500, 1500. 3 plus 1000, 4000. Because when you select FD value, it is the total distance from the source to destination. It is source. The source. Destination is this. What about the third path? 2000, 2000, 2000, 2000. 4 twos. 8000. Always EHRP will calculate this FD value and AD value. And in multiple paths, when EHRP is maintaining multiple paths, the path which has the least FD value is called successor route, and the successor is the best to reach the destination. That is the best path. So here above one, the first one is the successor. This will be the successor. And the next one is called feasible successor. Feasible, yes. This is what feasible successor of it is. So AD value is a distance from the neighbor. The first one will be 1000, and the second one is G is the neighbor, 1500, 1500. It will be like 3000 as well. And F, it will be calculated F, G, H, C. It is 6000. Always FD value will be greater than AD value. This is how EHRP is going to operate. But if you see in a big high level, if I'm going for Google, you have the EHRP metric calculation formula. If you take, there is a bandwidth. Okay, there are some other values are there as I said. See here, if you calculate here, metric is equal to 10 power 7 slash bandwidth plus load, delay, then reliability, into 256. Metric is equal to 256. But the same thing, since the K value is sub 0, 256 10 power 7 slash bandwidth total delay by 10. So this value, it uses this metric calculation, and it gives you something called as FD value, visible distance. Yeah. Metric is equal to 56 multiplied by 10 power 7 slash bandwidth plus delay. So let's configure the EHRP. Understand how AHRP is going to work. AHRP is a 100% loopless routing protocol. Because why loopless is, it is enable the split horizon rule. Understand this. All these are the technical words. Split horizon. According to the split horizon, the route that is advertised on the interface will not re-advertise back again. Means the router 1 advertise 10.0.0.0 router to B. Again router B will not advertise that route to router A. But whereas in the case of RIP it happens. RIP, what does it do? RIP is going to advertise the particular route for every 30 seconds. Router 1 is advertising to the router B, D and C. It will wait for next 30 seconds, again same thing is going to re-advertise. That can cause some bridging loops, or that causes some the route loops actually in the network. But no loops will be there in the AHRP just because of split horizon rule. Because yes, it will it do something called like load balancing and equal cost load balancing and equal cost load balancing. It can do summarization at the same time. It supports multi-protocol of IPv4 and IPv6. And AHRP is the only, it does like incremental updates. AHRP works very faster protocol comparing with any other protocol as well. Because of its timers. Because AHRP sends for 5 seconds hello message and 15 second hold time. If router 1 does not receive hello message from router B for 15 seconds, it will discard that router B is down. I'm going for router 1, config D, router AHRP 1, for example. Start on my system. I'm giving network, so I give 199.10.1.0 space, it's subnetted, so I must give subnet mask. Router AHRP 1, network ID, and subnet mask. Again, network, which I have my LAN network is 192.1.1.0. Let me give the default subnet mask, no problem. I must use the command no auto summary. I want to summarize to the default class. Then now I said once you configure AHRP, this router 1 continuously sends hello message. I want to debug the AHRP packets. See, router 1 is sending hellos on the giga interface on the serial. It's sending hello, hello, hello. But router 1 did receive router 2 any hello message? No. So stop you all, use space all and debug all. And if I type show IP AHRP neighbors, say I don't have any neighbor. So AHRP neighbor is the process 1. Soon after you configure router in router 2, see what happens. They must be in the same AS number, router AHRP1. Now, give network, which is 199.10.1.0, 255, 255, 255, 252. Soon after I give enter, you see something called neighbor 110.1.1 is there is some agencies are happened, neighbor agencies, neighbors are established. Then I want to advertise network which is 10.0.0.0, 255.0.0.0. Also I have a network of 400, 10.1.0, 255, 255, 255, 252 I have to advertise. Type the command for auto. Case of router. Now in the router one again, if you try to debug the message, debug EIGRP packet, it is sending now and also receiving. You see, received hello message. Stop you all. That is received hello from serial 00 neighbor 110.1.2. Who is 110.1.2? That is router 2. So router 2 send hello message to router 1. So internally, even though if they makes neighbor, once they advertise the networks also, still continuously they internally they send hello messages. Second router 3. Rotary HRP1 network let me and one mistake. Router B does not have 10, that is 172. So wrong advertisements if you have done. How you do again? I go to config D, router EHRP1. You have to delete that route. You don't have 10. No network. The network is 172.16.00. What networks we have? This we have to advertise. 172.16. So router EHRP1 network is 10.0.0.0 and 255.0.0.0. You see the agencies are not happened because you have to do the serial. With network 200, 10.1.0, 255, 255, 255, 252. You see sooner if I give enter, the neighbor is up. Your agencies come. And I told you must be the command water song. This is how you configure the HRP. Router 1, 2, and 3. So in the router 1, the verification command is show IP route. When you type the command show IP route, you see you have the routes of these. DT. So D indicates that these are AHRP routes. D indicates that they are the AHRP routes. Second type show IP AHRP neighbor. The router one has one neighbor. And also I can type show IP AHRP topology. So when you type this show IP AHRP topology, you get all the routes. How many? There is a successor, there is FD value. FD is this FD value and AD value. To reach 10,000, this is the feasible distance, advertised distance. Then also we have the other show commands, PHRP traffic. When I type the command show PHRP traffic, hellos signed 213, received only 81. Update sent 4, received 5. No queries, but there is acknowledgements are there. These are the drop message, high watermarks are different as well. Okay. So these are the different types of the show commands we do. Show IP, PHRP, neighbor. Show IP, PHRP, traffic. Show IP, PHRP, topology. Show IP, PHRP, route. Show IP, PHRP, show IP route, PHRP. Show IP, PHRP, consumer. Interface, traffic, topology, neighbor. These are the different types of the show commands. Okay.
Okay.
So what I do, take this pic, take the pic. You have to do the lab.
Okay.
You have to do the lab. Hello, Rafiq. Rafiq, you are there. You start the doing lab, Abdul. So, Pranay,
Yes, sir.
you is the host. You share the screen.
Can I share my screen?
In the Zoom option, in the Zoom setting, you'll have an option to share.
Yeah.
Share.
Yes, sir. Is it visible?
So you minimize. Open your Cisco packet tracer now.